Welcome to the deep dive. Today, we've got a really interesting piece to dig into with you.
Yeah, it's a thought leadership article from Sean Conway, who's the CEO and founder of ICSO. It's called How We Decide.
And we love getting to the heart of things, and this article really tries to unpack the evolution of decision making.
It does. It looks at Conway's own sort of personal journey with this topic and the thinking behind his company, ICSO.
We're going to explore how technology, especially over the last 20 years or so, has just fundamentally shifted how we even approach making choices.
Exactly. And what I find really compelling is how he connects these pretty advanced ideas back to his own starting point. It wasn't about fancy tech initially.
No, it started with a really basic question, didn't it?
Deceptively simple, yeah. What does making a decision actually mean?
He takes us back to, what, 2004? At the London School of Hygiene and Tropical Medicine.
That's right, Professor Jack Dowie's course, Human Judgment and Decision Making.
And that central question grabbed him. What does making a decision actually mean? Not just did it work out, but the actual mechanics of choosing.
Yeah, the process. And the tools they were using were interesting too. Not your standard stats classes.
What kind of things?
Influence diagrams, thinking about probability trade-offs, and even the language was different. Preference, utility, regret.
Okay, so less about just averages and more about the structure of the choice itself.
Exactly. It contrasted quite a bit with the standard evidence-based public health approach back then, which was very focused on like frequentist stats, Cochrane reviews, that kind of thing.
So this was digging deeper into the cognitive wiring almost.
You could say that. And Conway says combining this with his work in really complex health systems, it led to a big insight.
Which was?
That decisions aren't just isolated events, they're systems.
Systems. Okay, meaning you can design them,
Yeah.
analyze them.
Precisely. You can design them, audit them, see where they break down, and make them better. It's a powerful shift in perspective.
And that led him to focus his PhD research on this whole area.
It did. But he notes that back then, around 2003, the digital tools were pretty basic compared to now.
Like what? Static flowcharts.
Yeah, static decision trees, he calls, and desktop Monte Carlo simulations run on one machine. The idea of having real-time decision support, pulling in loads of data from everywhere, that was still science fiction, basically.
Okay, so fast forward 20 years, as he puts it. The landscape looks completely different.
Totally different. And he points to a few key things that made this massive shift possible.
The first one he calls the substrate, Web3 and permissionless compute.
Let's unpack that a bit.
Yeah, so how does blockchain, this whole decentralized web idea, actually change decision-making?
The really big deal with blockchain and smart contracts is that you can have logic rules that are guaranteed to execute.
Guaranteed how?
Because they're written in code on a distributed network. Once deployed, they run automatically when conditions are met. And crucially, there's an immutable record. Everyone can see what happened and that it can't be tampered with.
So instead of like guidelines in a binder on a shelf.
Exactly. Or a PDF on an intranet that people might interpret differently or just ignore.
You encode the rules, say, for allocating a budget or triggering a payment for a climate credit directly into the system.
And it just happens. Transparently. Auditably. It takes a lot of the ambiguity and potential bias out.
He also mentions crowdsourcing human values, using tokens. That sounds pretty futuristic, too.
It's a fascinating idea. Imagine people using digital tokens to signal what outcomes or principles they prioritize.
And that signal could then directly influence how these automated decision systems work.
Potentially, yes. It's a way to try and bake community values directly into the technology, a very ambitious goal.
Okay, so Web3 provides this trustworthy automated substrate. Then he talks about the catalyst, modern AI.
Right. AI is the second big piece. Things like transformer models, vector databases, streaming inference.
These are the tools that let us handle massive amounts of information in new ways.
Absolutely. Think back to his PhD prototype in 2005. He probably had to manually engineer all the features, telling the system exactly what to look for in the data.
Right, very labor intensive.
Now, with these modern AI techniques, especially transformers, which are amazing at understanding context, and vector databases for finding similarities, you can just feed them vast amounts of unstructured stuff.
Like what kind of stuff?
Remote sensing data, lab notes, social media sentiment, articles, all sorts of things. The AI can find patterns and insights without needing nearly as much pre-processing or explicit instruction.
So AI becomes this incredibly powerful pattern recognition engine working at a scale we couldn't manage before.
Precisely. It unlocks the potential in all that messy, real-world data.
And the third element he calls the compass, Causal reasoning, this seems critical. Moving beyond just correlation.
Yes. This is about understanding why things happen. He credits Judea Pearl's work here, the do calculus.
Okay, so it's not just A and B happen together, but if I do A, will it cause B, and by how much?
Exactly that. It's about interventions and effects. Causal models let you take those narrative theories of change, the diagrams organizations use to explain their impact,
Like log frames, yeah.
and turn them into explicit, testable models. You can ask counterfactual questions. What would have happened if we hadn't done this? You can even try to discover causal links from the data itself.
That's huge for making sure interventions are actually effective, not just coincidentally linked to good outcomes.
It really is. And Conway sees this convergence as key. Transparent data trails from Web3, scalable pattern finding from AI, and now maturing causal reasoning.
Putting it all together gives you this end-to-end pipeline.
Yeah, for estimating causal effects, maybe even encoding those into smart contracts, automating incentives based on proven impact, it's a powerful vision.
But he brings us back down to earth a bit with Professor Dowie's mantra.
Ah, yes. No probability exists in a vacuum. Context matters.
Which leads into Bayesian inference, the idea of priors and posteriors.
So the Bayesian idea is basically that we never encounter new evidence with a completely blank slate. We always have some existing beliefs or assumptions.
Like our priors.
Exactly. And these priors shape how we interpret new information. The new evidence updates our belief, resulting in a posterior belief.
Which is a blend of the prior belief and the new data.
Correct. And the strength of the prior really influences how much impact new evidence has.
He uses that great example of the two labs testing a new device.
Yeah, the sequencing devices. Both labs see the exact same evidence, one failure.
But they reach different conclusions.
Because they started with different priors. One lab was already pretty confident in the platform's reliability, a strong prior, so one failure didn't shake their belief much.
While the other lab was more skeptical to begin with.
Right, they had a weaker or more skeptical prior. So that same single failure had a much bigger impact on their final assessment. It lowered their confidence significantly.
It really shows how context, expressed as these priors, shapes the entire decision pathway.
Absolutely. It's not just about the raw data, it's about the lens through which we view it.
And Conway then scales this idea up massively, talking about priors at planetary scale.
Yeah.
Using Google search and social media as examples.
Yeah, this is mind-bending stuff when you think about it. Take Google's PageRank. Originally, the prior was pretty simple, right?
Basically, all web links were treated more or less equally at the start. An uninformative prior, he says.
Right. But it evolved hugely. Now, Google uses an incredible amount of context to create a prior for your specific search.
Like my location, my search history, what device I'm on.
All of that feeds into a personalized prior about what results are likely most relevant to you. If you search for Mercury, Google needs to know, based on context, are you likely looking for the planet, the element, the car, the singer?
And that contextualization turns it from just an index into this, what does he call it, a near prescient oracle.
It feels like that sometimes, but he immediately flags the flip side.
The immense gatekeeping power this creates.
Exactly. The system isn't just finding information, it's deciding what information based on its inferred priors about you.
And the same dynamic plays out on social media feeds.
Totally. Remember early Facebook. Chronological feed. A very simple, flat prior.
Now it's all about engagement.
Right. Every share, click, even how long you pause on something, it all refines a personalized prior about what content the algorithm thinks you'll find irresistible.
Which, as he points out, can have unintended consequences, like amplifying outrage because outrage drives engagement.
Yeah, it can create these feedback loops, potentially reinforcing biases or creating echo chambers. The system learns to give you more of what keeps you hooked, which isn't necessarily what's most informative or balanced.
So these systems, these context-aware ranking algorithms, haven't just changed information access.
They've reorganized attention, public discussion, maybe even democratic processes, Conway argues.
Which is why he stresses the need for transparency around the priors embedded in these systems.
Precisely. Whether those priors come from expert opinion, historical data, or policy rules, making them visible, maybe even adjustable, is crucial. We need to know what assumptions are driving the outcomes.
And this all ties directly into the work ICSO is doing, the Internet of Impact.
Yes. Their ambition is essentially to operationalize all this decision science, to embed rigorous decision logic into economic transactions, specifically for systems designed to generate positive impact.
Like climate markets, skills funding, managing health data.
Exactly. He describes these domains perfectly as fundamentally being sequences of decisions under conditions of uncertainty with competing objectives and asymmetrical information.
That's a mouthful, but it captures the complexity. And Ixo's approach uses design axioms from his old LSHTM notes.
Yeah, borrowed straight from Professor Dowie's course. 3 core ideas.
Okay, what are they?
1. Frame every material choice explicitly. Spell out the options, the objectives, the trade-offs. No ambiguity.
Makes sense. Get it all out in the open.
2. Couple judgment with evidence through modeling. Use probabilities, utility-structured thinking, not just gut feelings or who shouts loudest.
So base decisions on analysis, not just intuition or authority.
Right. And 3, record and review. Create that audit trail. Treat every decision as a learning opportunity.
Frame it, model it, record it. Simple but powerful.
Very. It's about building systems for better choices.
He then talks about Ixo's agentic oracles. How are these different from, say, those old static decision trees?
They're described as microservices that combine a few things: cryptographically signed claims, causal and probabilistic reasoning, and verifiable attestation.
Okay, sounds complex, but the key seems to be blending old and new.
Exactly. He mentions using established methods like multi-criteria decision analysis or MCDA, something Professor Dowie would recognize.
That's about weighing different factors in a decision, right?
Yes. But they combine that with modern deep learning for inferring the scores for those criteria in real time based on incoming data.
So AI does the heavy lifting on evidence extraction.
But the final aggregation, how the different factors are weighed and combined to make the decision, remains interpretable. You don't lose sight of how the decision was reached.
That seems important, avoiding the black box problem with AI.
Very much. And related to that is the emphasis on the do-why.
Understanding causation, not just prediction. Why is that particularly important for impact programs?
Because in impact work, you don't just want to predict an outcome. You need confidence that your intervention is actually causing the positive change.
Otherwise, you might be funding something that looks good, but isn't actually making a difference.
Precisely. So using Pearl's framework and tools like the do-why library allows them to explicitly state their causal assumptions, calculate the potential causal effect of an action, and test how sensitive that estimate is.
Stress testing the model, essentially.
Yes. And embedding these causal graphs with their on-chain oracles means they can provide not just the how much, the quantitative impact estimate, but also the executable, auditable why.
It builds confidence in the link between action and outcome. This leads him to lay out some core design principles for these kinds of next-gen decision systems.
Yeah, these principles tie everything together. First, make assumptions visible.
Statistical priors, ethical rules make them explicit, machine-readable, published.
Exactly. Second, fuse correlation and causation. Use deep nets for finding patterns, but use causal graphs to test those relationships. Don't just assume correlation equals causation.
Got it. What's third?
Keep humans in the loop, but at the right points. Automate for consistency where possible, but use human judgment for value calls, ethical dilemmas, setting objectives.
So leverage both machine efficiency and human wisdom.
Fourth, reward learning, not just outcomes. Treat every decision, every piece of data generated, as fuel for refining the models. Learn from failures as much as successes.
Continuous improvement baked in.
And finally, fifth, govern by protocol. Where possible, use transparent, tamper-proof logic like smart contracts for things like resource allocation or enforcing rules, rather than relying solely on opaque committees or individual discretion.
It's a call for designing decision-making infrastructure that is inherently more transparent, accountable, and adaptable.
Absolutely. It all comes back to designing better choices, making the process visible.
And that footnote about Professor Jack Dowie adds so much context to Conway's own journey.
It really does. You see how foundational Dowie's work was on decision tech, MCDA, prioritizing patient preferences in healthcare? He was a major figure.
And his teaching style sounds like it was quite impactful. A Socratic arena.
Yeah, challenging intuitive resistance to analytical methods, making people really think through the structure of their judgments.
And Conway highlights two specific assumptions Dowie's course detonated for him.
Right. First, the idea that technology is neutral. Dowie emphasized that models always encode values implicitly or explicitly.
That's a big one. Tech isn't value-free.
And second, the idea that institutions decide and people just implement. Dowie argued that people decide, and institutions should be designed to honor and enable good individual decision-making.
You can see the direct line from those insights to Conway's PhD, founding ICSO, this whole two-decade obsession, as he calls it.
Totally. It's about creating systems for agency choices that are explicit, auditable, and aligned with human stakes.
And that final thought from Dowie via Conway, transparent decision-making as a moral act, that really sticks.
It does. It elevates the whole discussion beyond just efficiency or optimization. It's about accountability and respect for the people affected by decisions.
Wrapping up, Conway's article gives us this really sweeping view of how decision-making is evolving, from theory to practice, powered by Web3, AI, causal reasoning.
Yeah, and the core message throughout is the drive towards making these processes more transparent, more auditable, more aware of their own underlying assumptions and context. That's what ICSO is trying to build.
So for you listening, the provocation here is maybe to think about those invisible priors in your own life. What assumptions shape the information, the choices you make?
Yeah, could making those assumptions more visible, more conscious, lead to better understanding or different outcomes?
How might these ideas apply not just in tech or big policy decisions, but in business, in your community, even in your personal life?
It prompts that question. What are the hidden rules guiding my own thinking, and how can I make more deliberate choices?
Definitely some food for thought there. Thanks for taking this deep dive with us into Sean Conway's ideas.
Great discussion. Until next time.